Welcome everyone to Digital Earth Academy. Now, the first thing I'd like to do is to respectfully acknowledge that the Denver Museum of Nature and Science is on lands traditionally stewarded by the Ute, Arapaho, Cheyenne, and Ochete-Chacoan tribes, and that lands all over the planet Earth have been and continue to be stewarded by Indigenous peoples. As we have the program today, there's a couple of ways you can interact with us. There's the chat where you can ask questions as they come up. We will save the questions till the end. We'll have some time to answer all your questions at the end, but whenever they occur to you, you can type them in and we'll keep track of them. There will also be some polls and some questions we'll ask you. And so you'll have a chance to respond to those. And with that, with no further ado, I'd like to introduce everyone to our geologist, Bob. Take it away, Bob.
Yeah, thank you, Mitch. Thank you all for joining us for Digital Earth Academy. And we're delighted to have you all participate in this program. We're going to be asking you some questions and we're going to be also giving you a poll where you can choose topics that we're going to dig into in more detail. So we'd like this to be as interactive as possible, and we are keeping an eye on the chat. So if you have a question or something's coming up, just mention it in the chat and we'll try to get to it. Also, we're going to talk for about 40 minutes. And our intention is to have what we call a soft close, meaning that those of you who have to scoot off to other activities, of course, we understand that. But if you want to linger for another 8 or 10 minutes when the show is over, we can answer additional questions at that time. So this is going to be a little bit of a hybrid presentation. We're going to have some satellite images of the Earth. We're going to have various data sets that we're going to show, reconstructions, and some actual experiments, some of which you can actually try at home. So let's launch into this. The title of our presentation has to do with climate change and looking at the changes that the Earth is undergoing right now. And I wanted to back out and start with the basic principles. And it's important to understand, especially for young people, that we are in a time of global knowledge sharing and global collaboration that has never existed before. And certainly in my lifetime, I'm seeing amazing things as teams of scientists around the world are collaborating and cooperating on topics, especially related to climate change and changes in ecosystems and systems of biological features, the plants, the animals, the people on the globe. And so this is a time of amazing challenge, but also amazing collaboration and cooperation to try to seek solutions. And we're going to emphasize solutions throughout our presentation today. We'll start out with a graph, and it's important to understand that the data are very important to us. This is a graph showing the concentration of carbon dioxide in the air, and it's obtained in Hawaii by a fellow named Ralph Keeling, and it's now being carried on by his successors. But this goes back to 1960 and then continues right up till today. And it shows the increase in the concentration of carbon dioxide in the Earth's air. It's named the Keeling curve, Keeling, K-E-E-L-I-N-G. That's named after the guy that started the measurements. And it is important to appreciate that the concentration of carbon dioxide, which is a greenhouse gas, has been going up systematically through my lifetime and through your lifetimes. And that's because we are burning fossil fuels, and the carbon dioxide from the burned fuels, which would be coal and natural gas and oil, and that would include gasoline in cars, that carbon goes into the air as carbon dioxide. And a woman named Eunice Foote was studying this back in the middle 1800s, and she discovered that if you put carbon dioxide in a glass cylinder and shine light on it, sunlight, that it heats up. And so Eunice, who was an early woman scientist, discovered the effects of the greenhouse gas, and many other people have worked on it subsequently. But the net effect is, as we increase the concentration of greenhouse gases in the Earth's atmosphere, they act like a blanket and the Earth becomes warmer. And I think we've got a warming video where the warm colors are shown in reds and oranges. And this is a timeline. It's advancing through time, but you'll see it get a little bit more and more orange as time goes on, and it might loop a couple of times. But the basic idea is that not all the same always across the face of the Earth, but gradually the surface of the Earth is getting warmer. And we can measure it in many different ways. And we've observed this in so many different data sets from around the world. You can see it getting warmer there, especially up in the high latitudes, up in towards the pole. And the polar zone, the northern polar zone is getting warmer particularly quickly because of the, we call it the albedo feedback. But what happens is as the ice melts that's on the ocean surface, it goes from reflecting bright white, which was reflecting the energy of the sun, to being dark colored water, which is absorbing the energy of the sun. So the polar areas are warming unusually rapidly. And we've got some folks from Kodiak with us today. And you guys have probably noticed your growing seasons are getting longer in Alaska. That's certainly something that is widely reported. But let's march on. And the other thing that is happening is the carbon dioxide that's in the air is actually getting into the oceans also. And what the effect there is that the ocean waters become a little bit more acidic. As you put carbon dioxide gas in the air over the water, it's absorbed into the water itself, and it makes the water a little bit more acidic. And this is changing the ocean ecology. The whiter colors there and the pinker colors are more acidic. This is again on a loop. So we're going, the old scene is now, and it's going to go to a younger scene, and you'll see it turning pink through time. And that's changing the ecology of the oceans. It's going to change the character of life for reefs and organisms that have calcium carbonate or limestone for their shells, because it's going to be more dissolving. So we've got big changes happening both on land and at sea. And speaking about sea, the other thing that's happening with the oceans is the water levels are going up. And this is another graph, the second graph for the show, the last graph, but it's again showing a change through time. And it's got mean sea level in terms of millimeters on the left-hand side. And then we're going from 1995 to about 2021 in terms of data. And you'll see that the level is going up, and that is implying that sea level is going up, and it's going up about the thickness of a penny every year. So not very much, but I'm a geologist and I think about geologic time. So that's got my full attention. And these data, this graph is coming from satellite data. There's actually satellites orbiting the Earth, and they're using radar to look at the surface of the ocean and measuring it very, very carefully. And the data are compiled by an organization right here in Boulder, Colorado. So if you poke at the internet, you're going to find this data set comes from the University of Colorado in Boulder. And the other thing is, sea level is going up, so that's a problem for coastal conditions. We'll talk about that later on. But there's also situations where areas that are dry are getting drier. And I think we've got a drought map coming up that is going to show you the effects here in the Western United States. And this is a map that is current. It's produced every Thursday. So this is from last week. And it shows in reds and darker browns where it's super dry. And I think you'll all see that the West Coast is pretty super dry. And for those of you who can pick out Colorado and Utah, you'll see the headwaters of the Colorado River. The Colorado River is born in Colorado and Wyoming, and then it flows down to the Gulf of California. And much of the area of the Colorado River has been in a drought for a long time. And why does this matter? Well, it matters because there's a lot of people, like 40 million people, that are drinking the Colorado River water down there and relying on it for their agriculture, their farming. And the water levels are falling drastically. I think we've got a couple of pictures of Lake Mead, which is on the Colorado River, and you'll see that the water levels have fallen dramatically. There's Lake Mead on the right. Here it is. You can see the bathtub ring, we call it, behind Hoover Dam. And why does that matter? Well, the city of Las Vegas is drinking the water out of this lake, and also we're generating electricity using hydroelectric on the Hoover Dam. And as we lose the water in the reservoir, we're losing our capacity to generate electricity. And of course, that's a big deal for the people who want to keep the lights on. I'm going to ask a question for you guys in the audience. Question one on our group, I'm not sure if we can paint it on the screen, but I'll just ask it, is have you experienced climate change yourselves. And I'm asking you to think about it, in your own experience. Have you noticed the climate is changing? Have you noticed it where you live? And I'm not sure if you can see the question, but we've got it asked there. And the question really is something you could answer in the chat, or you can mention it amongst yourselves. But I am expecting that more and more people will answer yes. And this is something that a few years ago, when I was a kid, for example, we didn't even think about climate change, and we certainly didn't mention it very much. So question to you on that one. And I'm not sure if I'm seeing any answers in the chat yet, but do think about it. But now we will ask a poll question. So we've gotten to a point in our conversation where I've introduced the basic framework. The world is getting warmer, sea levels are coming up, dry areas are getting drier, drought is a problem. Colorado is right in the middle of all of this, for those of you who are in Colorado. But now we've got some choices. We can talk about heat and drought. We can talk about wildfires and smoke. We can talk about water resources, whether there's too much or too little. And you guys can make a choice here. So each audience group or each participant, go ahead and fill in this poll, pick one of those 1, 2, or 3 there, and we'll wait a minute or two to get your answers in, and then we're going to direct the conversation along the lines that you guide us. And we'll probably talk about all of these topics in some detail, but we can prioritize our discussion according to your interests. So I'm going to grab a cup of coffee while you guys answer the question here. Okay. I've sucked down my coffee. I'm reading the chat. What are greenhouse gases? Well, I'll just tell you quickly. Greenhouse gases are gases in the atmosphere that interact with energy coming off of the surface of the Earth. So the surface of the Earth is reflecting energy back into outer space, and is super important. Some of the gases in the atmosphere, which is mostly nitrogen, which is not a greenhouse gas, but some of the gases in the atmosphere, like water vapor, like methane, like carbon dioxide, actually respond to the outgoing reflected energy from the sun. So the energy is trying to reflect back out into outer space, but it's hitting these molecules in the atmosphere, and it hits those special molecules, and it makes them wiggle faster. They absorb that energy, they wiggle faster, and as they wiggle faster, they're getting warm. So that's the effect. Okay, we've got wildfires and smoke is the leader, and then too much water is following up, and then heat and drought is the third. So let's go to wildfires. So wildfires and smoke, it's an interesting thing, which for those of us in Colorado, we've actually had this effect come close to us. But the Western US is drying out. We've talked about that. And we've talked about the fact that the Colorado River has been losing water, and it's because it's getting drier and it's not raining as much. And so the trees, which are the green things on this diagram, we're up at satellite level. We're looking at the Rocky Mountains in the Western United States, and you can see the green trees. Well, they've been suffering because of the dry conditions, and the dry conditions have created a good circumstance for bark beetles to infest the trees. And so we've got a situation in Colorado and in the surrounding states where beetles are killing the trees. And it's partly because it's getting warmer, the winters are warmer, partly because the trees are stressed because it's getting drier. But it's all worked out to be a perfect storm for the beetles. And the mountain pine bark beetle has been chewing on these trees. And Kachun's going to fly us in here close to, and we're near Grand Lake. So we're just on the west side of Rocky Mountain National Park. And from a distance, the forest might look pretty normal. But if you start looking closely at these forests, and I'd invite you to do this if you drive up in the mountains, look closely at the trees, you'll see there's a lot of dead ones. And the gray colors here, the top part of the screen, I think you'll see the trees are sort of gray looking. And they've actually lost their pine needles, and they're standing dead in the forest. Now there are little trees coming back, and there's some trees in some of the other little valleys here. So the trees are trying to come back, but we've lost literally thousands and thousands of square miles of forest due to these beetle infestations, which are a result of climate change. So as the climate is changing in the mountains of the Western United States and Western Canada, the trees are feeling it. And of course, it reflects back to the whole ecosystem. If the trees die, the animals that are accustomed to living in those trees, the birds that are accustomed to living in those trees, they suffer as well. So we've got a tremendous challenge in our forests. And we'll talk a little bit more about that here in a second, because the next thing that happens, as many of you know, is that lightning strikes or somebody's careless with a campfire and you get fires that get started. And we've had huge fires over the last several months, and particularly over the last couple of years. And many of you have heard about this. And we've got an image here that we can show of what the fires look like from space. And this is satellite level views. We're looking down from 100 miles up in the air, and you can see the effect of the fire burning. And this is in the Northwest. It's in Southern Oregon or Northern California. And you can see the big plumes of smoke coming up off that fire, and they're extending out towards the east. So you can see the wind is blowing from the west, and it's carrying the smoke to the east. And as that fire burns, the smoke keeps getting carried, and the next scene that we'll see is a smoke map. And we can map the smoke again using satellite images. So here, this is a NOAA, that's the National Oceanographic and Atmospheric Administration image of the smoke from fires in the west. The fires are out in California, the reds and the yellows, but the smoke, which is the blues and the greens, you can see it moves across the entire United States all the way to Washington, D.C. And many of you will remember this past summer and last summer as well. If you live in Denver or along the Front Range here in Colorado, you would have seen the smoke from these kinds of fires, and it came right across us, and it affected our air quality. The air quality in Colorado earlier this year was some of the worst air quality in the Western US, or in the world, actually. So this is a big challenge for all of us. But let's now go to the, I think it's the water question was the next one. And if we look at water, we've got this, there's sort of a paradox. And a paradox is a word that means it's confusing because there's two different signals. In some places we have too much water. In some places we have not enough water or too little water. And if we look at, we've talked about sea level a little bit. Let's talk about the sea level impact. And sea level, of course, is, it's far away from Colorado, but many of you have friends or family who live on the coast. It might be in Miami, it might be in New York City, it might be in California. And the coastal areas around the United States, which would include, places in Texas and New Orleans, down in Louisiana, are strongly affected by changes in sea level because they're literally built right on the coast. And we've got computer models that we can make that allow us to see the effect of sea level change on our coastal communities. And this is not, it's not very difficult science. We know the elevation of the coast very well, and we know the sea level change very well from that graph that we showed you a few minutes ago. And there's huge areas of Miami, which we're going to investigate right now, that are within only a few feet of the ocean level. And as the ocean level goes up, if there's a storm or if the wind blows too hard on shore, it will flood the coastal communities. And you can see here, the dark blue is the ocean, and part of Miami is actually on an island. But the lighter blue, if we switch it over to the lighter blue, are the areas that are going to be flooded in the not too distant future. And we know that's going to happen. This isn't a hypothesis. It's not really a question. We know the patterns very well. We know the elevations very well. And we can predict these changes that are coming. And they'll be coming in your lifetimes. And it's not just Miami. It's also going to be the other cities we talked about, for example, New York City, and of course, all around the world. The oceans touch everybody. So whether you're in Amsterdam or London or coastal Nigeria or coastal Bangladesh or in Shanghai on the coast of China, these sea level changes are going to impact you. And there are computer programs that you can touch on the internet that will show you the effects of sea level change on these communities. The other thing that happens, as we have a phrase that we say, the wet areas get wetter and the dry areas get drier. And we have started to experience unusual rainfall events. And some of you might remember that the Hurricane Ida came ashore near New Orleans, but it carried rainfall up into New York City area and flooded parts of New York, including parts of the subway in New York. There was some ghastly videos, which you might have seen on the internet, of the water coming into the subways in New York City. That's a very scary thing and something that might happen more, it will happen more in the future. But we've got a short clip from a flood this summer over in Belgium. And a fellow was trying to drive his car through the flooded streets. And I'm amazed that that car kept on going. So this was a big rainfall event in Europe. It affected Austria, it affected Germany, it affected Belgium, all the way down to Holland. And these kinds of scenes are going to become increasingly common as we get these unusual rainfall events where so much water lands on a city that there's no place for it to go except into the streets, and you get these tremendous floods. Mitch and his team at the Denver Museum have come up with an experiment to demonstrate this using a Lego city. And again, this is something you could do at home. You could build yourself a Lego city. We're going to take a Lego city and we're going to have a huge rainstorm on top of this Lego city. And we're going to take 500 milliliters of water, put it into a giant watering can and rain it on the city. And you can imagine what's going to happen. The water is going to hit the roofs, hit the pavement, and it's going to flow down this little edge here. And we're going to measure how much water flows off, which would be like a flood. So we're going to measure how big the flood was. And we're gathering the water here that came from that rainstorm. We're measuring it here in a graduated cylinder. And look at that. 330 milliliters of water came during that flood. Now we're going to change the situation by planting some trees, which are sponges. And we're going to put the sponges out there. We're going to have another rainstorm, the same kind of rainstorm, same amount. And we're going to watch the runoff. Now there's trees and vegetation planted. Those would be the sponges. And we're measuring the runoff. And here it is on the left-hand side coming in. Here's the results. Look at that. Only 140, about half as much water came off once we planted those plants. So this is an example of something that you can do. And you can do the experiment, but you can also plant plants in your community, and you can look at how rainfall events affect your community and think about flood-proofing the landscape around your home, around your community, and in your state. And in Colorado, we're actually doing that right now. And Kachun might be able to drive us in close so that we can see some of the construction that's been going on in City Park, which is right near the Denver Museum of Nature and Science, where we're speaking to you from. And we've had a big engineering project going for several years in downtown Denver, trying to figure out how to control stormwater. Because even in Denver, we get these big rainfall events. And I've driven my little red car through flooded streets, and I've been worried that I'd be stuck on the wrong side of the South Platte River because of flooding. And here in a golf course just north of the museum in City Park in downtown Denver, they've been scooping out big catchment basins. And the idea, they look like little lakes, but the idea would be that if there's a big rainstorm in downtown Denver, that the water would be held in these ponds on the golf course and would have a chance to slowly seep into the ground rather than running off in a giant flood. And so that mirrors exactly the Lego City experiment that we did a few minutes ago. And you could do that in your class. And Mitch and Asa figured out that if they use sponges, it would be sort of like planting trees in a Lego city. So I would encourage you, if you're interested to do the experiment, you could build a little city and see what happens when it rains on the city. And that would be similar to what we are doing here. So let's turn, we will cover heat just a little bit here. And I might ask you the same question, or I'll ask you another question that says, well, you know, have you guys felt, you know, unusually hot weather? And I'm asking that as a question to the community, and some of you are in Denver and some of you are other places, but have you experienced a heat wave? And then we'll talk about some possible solutions, including planting trees or maybe even painting roofs a different color. Let's look at this in a little bit more detail. I think we've got a map, Kachun, of the heat wave that was in the Pacific Northwest earlier this summer. And if you look at the area around, it would be up around Seattle and in that country. If we could look at the heat wave map, again, it's going to be red is going to be hot, and the hotter areas were super hot. This is a map of, it'll come into focus here in a minute, but the
Hey, Bob, it is up.
Bob seems to have frozen, but that other voice you hear is Kachun. And Kachun, what can you tell us about this map?
Yeah, so this is a map from the heat wave from earlier this summer. As you can see, it's dated June 28th, so just a few months ago. And the colors represent how hot it got throughout the Pacific Northwest. And so you can see by the bar at the bottom, you know, there are some towns that were getting 120 degrees Fahrenheit. And that's extremely, extremely hot. I mean, even for us here in Colorado, or even for people in Arizona, it's rare to find temperatures that hot. But for people in Seattle and in Portland, and even in Canada and British Columbia, where a lot of homes don't have air conditioning because they never really expected this, this was a very unusual event. But like a lot of other similar types of events caused by climate change or global warming, this is sort of the type of thing that we'll be seeing more and more. Now, another thing that I wanted to talk about, and hopefully Bob will be able to connect back. I think he's having internet problems up in Longmont.
I am back. I'm back. So
okay, here we go.
So Kachun, bring us down to Denver and show us a heat map for Denver.
Yeah. So I'm going to zoom us down to Denver.
So we're going to try to show the same color scheme where red is going to be hotter, and we're going to be looking at our own town of Denver, and you can see that there's some areas that are bright red, there's some areas that are orange, and then there's some areas that are yellowish, and the brighter red are hotter, and the orangey are middle, and the yellowish are cooler. And you'll also see some of the park areas which are in green. And we call this the urban heat island effect. Cities tend to be hotter because they've got lots of dark pavement and dark buildings. And if there's no shade, it can get super hot in cities. And it's important to see that there's different temperatures in different parts of the city. And some parts of the city have more pavement and more hard surfaces, and they tend to get hotter. Other parts of the city have shady trees, and they tend to be cooler. And Kachun was interested in experimenting with this. And again, he did an experiment that you guys could replicate. He went out into the city of Denver with Asa and Mitch, and they measured the temperature in different places. And I think we've got a picture of Kachun out on the pavement here, and he's got he's got an umbrella so that the thermometer is actually in the shade. We don't have the thermometer's not in the sun, but Kachun, how hot is it there on the pavement in downtown Denver? This was a couple of weeks ago. Look at how hot it is. Kachun, oh my goodness, look at that. It's 101 degrees Fahrenheit on the pavement in downtown Denver. That is super, super hot. Let's go to a park area and a cooler area right near the museum. And we set this experiment up the same exact way. So the same thermometer, same umbrella, but Kachun is now standing on a shady spot in City Park. And Kachun, how does it feel to be in the shade where you are right there? Let's see what he's feeling. Look at that, 92 degrees. It's still hot, but it's not 101. So it makes a big difference to have a shady tree. And I think that's super important to appreciate, is that a little bit of shade can make a big difference. And we can make shade. You can plant trees. Trees make it cooler, something that you can do. We had another question, which was about the color of the ground or the color of the roofs. And we're going to go back to Mitch and Asa's Lego City and see what the temperature conditions are like in the Lego City. So here's the Lego City, and you can see the rooftops are different colors. Some are red, some are white, some are blue and purple, and some are really dark blue and super dark blue. And let's look at the temperatures. And we might hold the screen here for a moment, just so that you can see here, we've got the Lego City. Let's get those numbers back on the screen, or we can walk through it again. But when we get to the numbers, let's stop. And you'll just see that the thermometer, which is a digital thermometer like you guys have been using to check your temperature, is recording the rooftop temperatures of our Lego City. And the rooftops that are pale, like the white one, are at 67, almost 68 degrees Fahrenheit. And the hotter roofs are at almost 80 degrees. So a substantial difference in the temperature of the roof. And you can imagine if you're trying to keep the building cool, it certainly would be to your advantage to have a cool roof. So this again is an example of something that can be done, something that can be done by people, engineers and city planners and architects, people who are designing our landscapes. We can plant more trees. We can color the rooftops different colors, and we can make a difference in the quality of life in our cities. And most of the people in the United States do live in cities. 80% of the people in the US live in cities, and that's becoming true worldwide. So we need to figure out how to make our cities more livable in a time of climate change. The climate is changing, the earth is getting warmer, but we can make life better by using science and by using our engineering skills to make things better. We can make our cities cooler, more livable by thinking about things like planting trees, building more parks, building places for water to accumulate, and possibly even changing the color of the rooftops in our city areas. And I think that as we work our way through the program here, again, we want to hear from the audience. If there's anybody in the audience who has experienced some of these issues yourself, we would like to hear your impressions. But the point that I really want to make is that we live in these changing times. The world is a huge place, but it's a place where people are cooperating and collaborating from all nations. Hundreds of different countries are involved in studying climate and climate change, and the reports that are being put together by the scientists are integrating information from so many different people working in completely different environments. And we're looking at the changes that are being reflected not only in the cities, but also in the countryside, how it's affecting biology, which would be the plants and the animals. Some animals are having to move to cooler places or higher latitudes. Some plants are having also to move. And it's, of course, if you're a plant, it's hard to move, but the plants will gradually move as the environments change. And then, of course, our agricultural practices will have to change. As we look at the use of water, we can make tremendous differences in the way we use water to improve the efficiency of agriculture. We can grow crops more carefully using less water, and that's going to happen. In Colorado, where many of you live, 80% of the water is used for irrigating crops in Colorado. So that's the majority of the water is going to agriculture. And as we become more careful about how we grow plants, we may find different techniques. And I've seen that in different parts of the world. If you go to Africa, the Sahara Desert, which Kachun is showing you now, or if you go to the Middle East, like Israel and Jordan and Egypt, the people are definitely using water more efficiently. And here's a picture inside a greenhouse that I took in the middle of the desert. And the water is coming right to the roots of the plants in little pipes. So they bring the water in a little pipe. It goes right to the root, And even though we're in the middle of a desert, you can grow melons. It's amazing. And so we'll see practices like this that are being explored in super dry areas. We'll see them brought to Colorado. And in fact, we're already seeing that starting to happen. So we are starting to make the changes here in Colorado. And you're going to see more and more of that in your lifetimes. And some of you will have careers in science or engineering or architecture where you will be fixing some of these issues. And you'll stay in school, you'll go to college, and you'll go to graduate school, and you'll pop out as scientists who will help find solutions to some of these big problems. And of course, it's not you alone. You live in the context with other people who are working on the same issues, and many of your classmates and colleagues. And I'll just give a few examples. Amanda Gorman, who's a poet, and some of you might have heard her she recited her poem at the inauguration of President Biden earlier this year. And she says, "For there is always light, if only we are brave enough to see it, if only we are brave enough to be it." And what Amanda's thinking about with light here, she's thinking about knowledge and education. And you might be hearing from Amanda because she says she wants to be president of the United States. And I think she's about 23 or 24 right now, but I think some of you might someday be voting for Amanda Gorman. And she's a wonderful person, and you can find the YouTube of her giving her poem that she did on the Capitol back in January. Other people like Malala, some of you know Malala. She's the young girl who was attacked by the Taliban back in, well, it's now probably about 8 or 10 years ago, but she lives in Swat Valley in Pakistan, where I used to teach. I worked in Pakistan for many years, and I was a teacher there. And Malala was a young student, and she was attacked because she was a girl going to school, and some of the conservative people didn't want girls to go to school. And she says one child or one teacher, even one pen or pencil, one book can change the world. And she knows what she's talking about because she's seen it. She's lived in that experience. And then many of you know Greta, and Greta says the same thing. If you listen to Greta Thunberg, who's a Swedish young girl, and again, she's still probably in college, but she says right here, right now is where we draw the line. Now, the world is waking up, people are becoming aware, and the change is coming whether you like it or not. And she's talking to the adults, and she started out, many of you hopefully know that she started out as a very young student and was protesting climate change and trying to get older people to listen to her. And she became a very dramatic voice of your generation. She spoke to people across the whole world. She came and gave a talk in Denver, which I actually went to about 2 years ago, maybe 3 years ago now. And she spoke to the United Nations. She's spoken to many European leaders. So people are listening to the young folks. They're listening to your generation. And to be very honest, we, and I'm speaking as an older person, we hope that you, younger people, find answers to some of these questions and some of these challenges that we're facing around the whole world, and that you join forces with your friends and colleagues in every different country on the face of the whole world, and you find ways of which we can make the world a better place. And it's certainly going to include changing our energy use. We're going to stop burning fossil fuels, means we'll stop burning coal, we'll stop burning natural gas, we'll stop burning gasoline, we'll stop burning oil, and we will generate electricity using renewable technologies, some of which haven't been invented yet. And it'll be, of course, things like photovoltaics and wind, but there'll be other things and other energy sources that you and your colleagues in your generation will come up with. So I have a great optimism for the future. I think it's going to be wonderful, but there are definitely challenges. And it's going to need an entire generation of workers who will be scientists, engineers, and social workers and others who will keep society going smoothly. And we are at a cusp of great change, but also of great excitement about looking into the future and finding out how to make the world a better place. And we've arrived at about the 40-minute time point here. And what I'd like to do is, again, sort of a soft close. Those of you who need to head out, please feel free. But if you've got time or interest, or if you can stay for 8 or 10 more minutes, we can happily answer questions. And maybe Mitch, you could look through the chat or come up with some questions, and we can see where the conversation goes.
Absolutely. We've got a few questions already, but of course, it's not too late. If anyone has any questions, type them in the chat. We have a question. Why is it bad if there's too much water in certain places?
Okay, that's a good question. So one of the things that we've discovered, partly by measuring and partly by computer modeling, is that the areas that are relatively dry are going to get drier as it gets warmer. And the areas that are relatively wet are going to get wetter because there's more rainfall events and there's more energy in the atmosphere. So the precipitation or the rainfall goes up. And why does that matter? Well, it matters because you get increased flooding and you get waterlogging, and land that was usable becomes swampy. And so I think that if you were to think about Colorado, for example, only a few years ago, maybe 6 or 8 years ago now, there was a big flood in Boulder, and I live in Longmont, which is not too far from Boulder, and the flood in Boulder was very dramatic, and everybody was talking about it. But it rained not so much, but it rained a lot where I am, and I have a haystack that I use to feed my llamas, and the llamas like the hay, and the haystack got so much rain on it that it started to grow grass. There was grass growing on my haystack, and the hay got moldy, and the llamas didn't like it. So even me living sort of in a dry area, not too far, sort of out from the mountains, it affected me when it rained too much. So that's some of the ideas.
Yeah. So what are some tangible ways students can participate right now with climate change initiatives?
So that's a wonderful question. And I hope that we've given you a few clues. And I look at, for example, planting a tree. And it depends a little bit on where you live as to whether you've got a yard or some space where you can plant a tree. But if there's trees, it makes shade. And if there's shade, it makes your city cooler. So that's an example. And it doesn't need to be a whole tree. You could plant a garden. You could plant, something small. And, I really believe in green things. And, if you planted bushes, or if you planted tomato plants, and then you could eat the tomatoes. So I think all of you can plant a plant, and that's doing something nice for the environment.
Yeah. And we have another question. Some people who live in Denver are not near the wildfires, but how are they affected by the wildfires here in Denver?
Well, sure. So those of you in Denver this summer, if you looked at the mountains, in fact, there were times when you couldn't see the mountains because the air was so polluted. And that pollution was mostly smoke. And the smoke was coming from the fires in Western Colorado partly, but also in Oregon and California. And the air quality in Colorado was among the worst in the entire world for several days this past summer. And that affects your health. If you breathe the smoky air, it can, if you have asthma or if you have breathing troubles, it can exacerbate or make worse those problems. So it can definitely affect you.
Yeah, I have asthma and I can attest to that. That is absolutely true. So we have a student who's concerned to know if his generation is going to drown from climate change.
Well, I mean, I'll take that question a little bit spiritually. I mean, literally, you're not going to drown, but you might think you might drown emotionally. And there's a cartoon in the Denver Post today. If you guys get the Denver Post, you'll see a small child carrying the weight of the world on her back. And that's in the Denver Post today. So our generation, meaning old adults like me, we're worried that you're carrying the weight of the world on your shoulders and you might drown in climate change, not just literally from too much water, but from the overall impact of it on your lives. And I think the answer to that is you wear a life vest. and you do what Amanda Gorman recommends, is you look at the light and you think about it and you find solutions. So don't drown, wear a life vest, plant a tree, figure out ways to work with your community and with your classmates to find solutions. And I don't have all the solutions. I don't have all the solutions. You're going to have to find some of them yourselves.
Yeah. And so here's another question. What is more effective, recycling, composting, both?
The answer, I think, would probably be both, but it depends a little bit on where you live. And I might say that recycling is a challenge for all of us, just because we've got to move so much stuff and then process it. So I might even start earlier than that and say, well, if you go to a store and they offer you a plastic bag, you can say, no, I don't need a plastic bag. I've got my own bag, or I will take a cloth bag or a paper bag. We need to reduce the amount of material that needs to be recycled. So think about that in terms of your purchasing. And we often point out that one of your greatest strengths for influencing a situation is where you spend your money. So as you guys grow up and you're spending money in food stores and restaurants and one thing and another, you can deliberately purchase things that have less plastic, less packaging, so that there's less need for recycling. Of course, recycling is good and we should do as much of it as we can. And composting is also good. Composting, if you've got your garden and you're growing your tomato plant, I think you can all grow a tomato plant. You could have a little bit of compost that you could add to the soil that would make the tomato plant grow even bigger. That's a good thing.
Yeah. And someone else asked, how can planting just one tree help the environment?
Well, do you know how many people there are in the world? That's a number that we don't really know the answer to, but it's 7.5 billion. So that's 7,500 million. So there's a lot of people in the world. And if every one of those people planted one tree, it would make a lot of trees.
Yeah. All right. Well, that's about the questions we have. And I think we're about at time. Thank you, Bob, for leading us through this. Thank you, Kachun, for piloting us all around the world. And thank you, everyone, for joining us. And any final thoughts, Bob?
Well, I'll just say about trees and planting a tree. I live in Longmont and I plant trees. And every once in a while, the tree doesn't survive. I've got somebody that eats a fruit tree and kills them. And then some beetles ate one of my pine trees and killed it. And I planted another tree. So I'm still planting trees.
All right. Wonderful. Well, thank you so much, everyone, for joining us. We had a great time. I hope you did too. And yeah, have a wonderful afternoon.